Hello and welcome to Quick Maths Revision, where today we're going to be going over how to convert from recurring decimals to an exact fraction. So before we go into how to convert, it would make sense to first understand what is a recurring decimal. So a recurring decimal is one where we have a repeating number of digits after our decimal place. So if we had, for example, 0.7777, where the 7s go on forever, that is 0.7 recurring. And we don't have to have just one number repeating itself. We could have 0.414141, where the 4 1s repeat forever, and that is 0.41 recurring. And you'll see that the notation for a recurring decimal is we draw the dots above the numbers that are repeating themselves. So if we had 3 numbers repeating themselves, like 0.231231, where we had 231 repeating itself, that would be 0.231 recurring. And what we do is, rather than drawing dots over every single one, we draw the dots over the end two, which contain everything that repeats itself. So now we know what a recurring decimal is, we can go straight into how to convert from recurring decimals to fractions. So there's a bit of a trick with this. So if we had 0.333, where those 3's repeat themselves forever, we know from what we've just done that this is 0.3 recurring. And what we're going to try and do now is write this as a fraction. So the first step with all of these questions is we write x is equal to whatever our number is that we're trying to write as a fraction. And you'll see why this works now. So what we're going to do is, the trick is we want to try and get rid of all of the numbers that are repeating themselves after this decimal place here. So if we multiply our x by 10, what we've got is we're going to move every single number one space to the left. So we're going to have 3.3333, and we still have an infinite number of 3's after that decimal place. So now here comes the trick. What we're going to do is, if we subtract x from 10x, you'll see that all of these 3's after the decimal place will cancel each other out. So if we have 10x minus x, this is the same as 3.333 minus 0.333. And as I've said, all these infinite 3's cancel each other out. So on the left hand side we have 9x, and then on the right hand side we just have 3, because all those 3's disappear. And now it's just a simple case of rearranging for x, because as we've seen earlier, x is 0.3 recurring, so if we can get x as a fraction, then that's the same number. So x is 3 over 9, which, as they're both divisible by 3, is 1 over 3. So we now know that 1/3 is the same as 0.3 recurring. So there we go. So now let's do another example, but with the 2 numbers repeating themselves. So if we have 0.414141 ... we know that this is 0.41 recurring. And if we do, like we said before, set this as x. So the trick, as I said, was to cancel out all the numbers after the decimal point. If we did what we did last time, we'll see that this wouldn't work, that if we just multiply by 10, and I'll show you why this doesn't work. So 10x, we just shift everything one space to the left, like so, and what you'll see is at the top we have 4 1's repeating themselves, but on the bottom we have 1 4's. So if you subtracted one from the other, they wouldn't completely cancel each other out. So this is wrong. We won't use this. Instead, if we multiply by 100, we'll get 41.414141 ... and we'll see that again we have 4 1's after the decimal point, which is good, which is what we want. So now we'll do the same as before. We're going to just subtract them from each other so that we can rearrange for x. So 100x is the 41.41 ... and x is just 0.4141 ... So all the 4 1's cancel each other out, and we get 99x is equal to 41. And then when we rearrange for x, because x is 0.41 recurring, we get x is equal to 41 over 99, which, as I said, is our recurring decimal there. So that's basically the gist of everything we'll ever have to do with these sort of questions. But what I'll do is I'll do one last example, which is about as difficult as these questions can get. So if you were asked to write 6.2010101 as a fraction, doing what we've done before, we have 6.201, where only the 0 and the 1 are repeating themselves. So this is a bit complicated because this 2 here isn't repeating itself, but it's behind the decimal point. So what we'll have to do is we'll have to correct that by moving it across, but we'll do that in due course. So yet again, set x equal to our number, and then we'll do 10x, because as I said, we need to get this 2 out of the side where the repeating 0, 1s are, so we just have the 0s and the 1s after the decimal point. So we're going to have 62.0101, and then I'll skip the step where we times by 100 because we know that doesn't work, so instead we'll just skip straight to 1000. X is equal to 6201.0101 ... And then now what we're going to do is we want to subtract so that all of our repeating 0, 1s cancel each other out. So we're going to use the 10x here and the 1000x, because all these repeating 0, 1s will cancel each other out like they did in all the other examples. So on the left we have 1000x minus 10x, and then on the right what we have is 6201.0101 ... and 62.0101 ... So on the left we're just going to have 990x, and on the right we're going to have all these 0, 1s cancel each other out, so that's a 0 there, and then what we're going to do is just do some subtractions, so that becomes a 10, and then a 9, then 11, so then 11 minus 2, 9, 9, 3, 1, and then a 6. So we have 990x is equal to 6139. So when we rearrange for x is going to be 6139 over 990. So as I said, this example here is about as difficult as any of these questions can get. It's just simple. The more you do the process of just plugging it in, multiplying, and then subtracting them away, you'll just get used to it, and that's really all you need to know to be able to do this. So hope you found this useful, and you should now be able to answer any questions you have on converting from a recurring decimal to an exact fraction.